dividing polynomials with missing terms. So I'm going to try and show you the correlation between these two. So here's 3009. 3 goes into 3 how many times? Once. Where do I put the 1? Over the 3, because we're talking about just the 3. So 3 goes into 3 once. 1 times 3 is 3. Draw the line and change the sign. 0. Bring down a 0. Why do I have to bring down a 0? Why don't I just go straight to 9? Just the way you were taught. Okay, well, let's understand why you were taught that way. If I ignored the zeros, I would be dividing 3 into 39. What is 3 into 39? 13. 3 goes into 0, 0. 0 times 3 is 0. Subtract nothing, you get nothing. You bring down nothing, you get nothing, right? And it sounds silly to do all this process, but if we didn't bring down the zeros, we would get, if we didn't bring in the zeros, we would get 13 instead of 1,003. So now I'm going to show you how this relates to this. We need the zeros because this is the ones place. Let me erase this. This is my ones place. This is my tens place. This is my hundreds place. And this is my thousands place. Without those place markers, we would just have 13, right? Okay. So this time I've got x cubed minus 1. What place is x cubed? If this is the ones place, there's no x squared. What else isn't there? There's no x. So we're missing places, right? Let's take a side. What if I had b to the 7th plus b squared plus 2? What am I missing? Start with b to the 7th. What am I missing? b to the 6th. I don't have one, right? There's none. What else am I missing? b to the 5th. What else am I missing? b to the 4th. What else am I missing? b to the 3rd. I've got b squared. I don't have a b. If I were to put this in place value, this number would be 1,000,001,02. It would be 10,102. It's not just b to the 7th plus b squared plus 2. It's b to the 7th plus nothing in this where there's with an exponent of 6 and nothing with an exponent of 5. Those are place values in math. You don't normally write it like that. Do you see what I'm saying? Do you normally see something like that? I have none of those, none of those, none of those, none of those. You do in numbers though, we have to put them there, or else you wouldn't know. Right? You starting to kind of see it? So, what would I have to do with this one? It's not just x squared. I'm sorry. It's not just x cubed. What am I missing? An x squared. And I'm also missing an x. You have, because you're saying I have no x squareds and no x's. Makes sense, yeah? X minus 1. So I need a ones place, a tens place, a hundreds place, and a thousands place. Now we can divide. X goes into x cubed how many times? X squared. Where am I going to put the x squared? Over 0x squared. It goes in the hundreds place. X squared belongs with the x squared. X squared, now I'm going to multiply. So that's my division. Now I'm going to multiply. X squared times negative x is negative x squared. X squared times x is x cubed. Draw the line. Change the sign. I'm left with, move this up. I'm left with, what is 0x squared plus x squared? If you have no x squared and I have 1x squared, how many do we have together? X squared. X cubed minus x cubed, that goes away, right? That's nothing. Bring down the 0x. It may seem like you don't need it, but you do. Okay, x goes into x how many times? X. It goes over the x. What's really nice about this is you can see if you mess up, because if I were to say 1, well, I wouldn't have anywhere to put 1. You know what I mean? You know the next one has to be an x. And the next one after that has to be a constant. Okay? It'll always go in order like that. All right, so x times negative 1. Let me change my color. Red. This is how bad I am. I got to do it the same way this is. So it's rainbow just the same. Okay. So x goes into x. We already found that. X times negative 1 is negative x. X times x is x squared. I'm going to draw my line and change my sign. This goes away. And I'm left with x. Bring down negative 1. Can you guys see that x minus 1 goes into x minus 1? 1. 1 times x minus 1 is x minus 1. Draw the line. Should have done with color. Right, Andrew? 1 times negative 1 is negative 1. 1 times x is x. Draw the line. Change the sign. This goes away. And I'm left with no remainder. There's my answer. Make sure you guys get a clean copy of that, please. Recording. Okay, so let's try one on your own.
Oh, no.
I know. Which term is missing? X squared is missing, right? There is no x squared. Is it missing anything else? What term should you insert here?
Probably or actually,
5x cubed plus 0x squared minus 4x plus 3. You guys ready to try one? Let's try another one. Which term is missing? X. So what are we going to add? 0x. You guys are so smart. Okay, good. So use it. This one doesn't even require dividing. You could factor. Divided by x plus 4 makes x minus 4. Right? Let's do another one. Do we need a placeholder for this one? Yes. Do this one for me. Do we have any? Do I have any? Yeah, let's just do this one. Do this one for me. Okay, so I've got a cubed. Guys, I told you 5, 4, 3, 2, 1, my turn. Matt. Frankie, there's that smile. Okay. A cubed plus what? 0a squared plus what?
0a.
No, I've got an a. I've got 8 a's.
Oh, yeah.
Minus 24. A minus 2. A goes into what?
All the orders.
Jesse, what does A go into? What am I thinking about here? What am I concerned about? A and what else? No. What am I concerned about? You tell me. If I'm dividing, what am I dividing? I'm dividing a cubed and what? And a. So how many times do I have to multiply by a to get a cubed? A squared. A squared. You see that, Jesse? So a cubed times what? What am I going to multiply now? That times, you do the ones place first, right? Times it by -2, which is -2a squared. Then I'm going to multiply it by what, Jesse? Well, we multiplied it by -2. That's the ones place. Now what are we going to multiply by? Huh? A, which makes what? A cubed. It's not pretty. So I've got -2a squared. I thought we agreed that it was appealing to the eye last time.
No.
Draw the line, change the sign, this goes away. I think we need to write here, under multiply, you want to multiply the ones place, and then the tens place. Well, you guys are forgetting on the process, right, Jesse? Have you written it down on your paper? Keep going, okay. Levi's moving me along. 0a squared and 2a squared make 2a squared. Bring down positive 8a. Now what am I concerned with dividing? The 2a squared and the what? And the a. A goes into 2a squared how many times? 2a. What am I going to multiply first, Jesse? Because I want to make sure that you're successful at this. 2a times what? -2, which makes -4a. Why do I leave the squared out where? Because 2a times a makes 2a squared. Right? We're trying to think of what times that is going to make that. So 2a times a makes 2a squared. Then we draw the line and change the sign. That makes this go away. Our goal is always to get rid of these, right? So 8a and 4a is 12a's. Is that right? Eduardo. I did. It was negative and I changed it to positive. Eduardo, what do I do next? What? Bring down the -24. Repeat. What am I concentrating on? 12a. How many a's are in 12a? 12. Look, isn't that nice and interesting? So it's a constant right above a constant. We must have, no. We must have done something right, right? Ah, did you see that? Oh, I caught my ring inside one of my loops, and it tugged on my ear. Oh, thank you. The recording. Okay. A goes into 12A 12 times. So 12, we're going to change our color to red. 12 times -2 is -24. 12 times A is 12A. Draw the line. Change the sign. This goes away. 0, and we're done. Closing thought? Closing thought? Closing thought?
That would really help me to understand it.
Alright.
So keep me picture of the window.
We'll go over it. 5, 4, 3, 2, 1, freeze! What did you learn today? Finding missing terms. We're adding it in there. Why do we need placeholders when using long division? Because you need placeholders when you've got zeros, right? When you've got thousands, you need a placeholder. Okay, find the missing dimension. Find that dimension. If this is a square, and this is one side of the square, and this is the other side of the square.
2x, negative 2x, minus 3. Yeah, minus 3.
Good. Most of you have it already. Hey, check this out. Doesn't this look like a division sign?
No, it looks like
It is part of the square. Division is the same thing, guys. Just like this, if I had a 6 and it was a box, what would this side be?
probably
The area inside of the box? We'll go over it in 1 second. So this is 2x plus 3.